Hello guys, welcome back to my channel. So today is the second class of linked list. Okay. So today we will do singly linked list. Okay. So before starting this, I request you to all please like and subscribe my channel. So let's move to the topic singly list. Singly linked list. Okay. So what is singly linked list? Singly linked list is a fundamental data structure. Okay. Forget to open Eclipse. So when I am explaining, then that time expl- Eclipse will open. Okay. So what is singly list? Singly linked list is a fundamental data structure. It consists of nodes. Okay. Where each node contains a data field and a reference to the next node in the linked list. Already discussed this thing. Okay. So what is singly linked list? We can understand this by with the help of diagram. We already saw this diagram in previous lecture. Okay. So So a singly linked list that is consist of data and that this one is pointer or you can say that reference of next node. Okay, that contains address of next node. Okay, so in first node that one is head node. Okay, which contains data and the address of next node. So all the nodes like that same data and address of next node. Okay, this is the diagram of singly linked list, and if last node that is that contains null means that is last node. Okay, so what is singly linked list is a fundamental data structure. It consists of nodes where each node consists a data field and a reference to the next node in the linked list. In the next of last node is null, indicating that end of the list. Okay. Linked list support efficient insertion and deletion operation. We already discussed this thing in previous lecture. Okay. So now we will understand what is the node structure. Okay. In a singly linked list, each node consists of two parts. We already saw data and a pointer to the next node. Okay. So this structure allows node to be dynamically linked together. In this way, all nodes means nodes which are dynamically linked together or forming a chain-like sequence. Okay. So what is the node structure? Here I am writing here node structure. Okay. So definition of singly linked list. So, how we can define the node structure? So, public class node, okay, class would be node, and it consists of data and node. Okay, so data should be integer type, and node that is next. Okay, so this is definition of node in a single linked list, and here we write constructor. Okay, to initialize the node with data. Okay, why we use constructor to initialize the data. Okay, so here we use constructor to initialize the node with data. Okay, so public node int data, this is constructor. Okay, you can say that argument constructor. Okay, and constructor, in constructor what happens, class name should be same. Okay, of constructor name. So public node int data, and in constructor if you write constructor then it is like this data equal to data, this next equal to null. Okay, so this is a node structure. Okay, I think we already wrote this thing. Node structure, sorry. So node structure here. Okay, we already discussed this thing. This one is node structure. Okay, let's move to the next topic, that is. So in this example, what we saw, the node class contains an integer data field, that is data, to store the information and pointer to the another node next to the establish the link to the next node in the list. Okay. So what we see in this example, the node class contains integer data. This is integer data. Okay, that is also called data. and to data means that store information, okay. And this one, and pointer to the another node, this is pointer to the another node, that is next. Next is pointer to the another node. We already saw na, in linked list which consists of data and pointer. So here data that is a um, integer type, okay. And here this is pointer, next is the pointer, okay, that store the information. A pointer to the another node, this is pointing to the another node, okay. So because of that, that establishes a connection, okay, or link to the next node, okay, in the list. This is used for the connection to the another node. So, and here we see operation here, okay, traversal. But how you can perform traversal of a single linked list? Traversal means simply it will go through each element, what element present in a linked list, and that is known as traversal. Okay, so traversal in linked list means visiting each node, okay, and performing operation like printing or processing it. Okay, so here I am writing a step. What is the step we take for a traversal of each node? Okay, firstly we initialize a pointer, okay, current to the head of list. Okay, so in this what we saw in diagram, firstly firstly we point this thing, pointer, okay, that is pointing to the head, okay, that is current node. Okay, so first step is initialize a pointer that is current to the head of list, loop through the list using a while loop until the current becomes null. Means the second step is that we will use while loop, and that while loop is run till when we get null. Okay, and third step is process each node. Example, print its data. Means third step is printing the data, and last one, move to the next node by updating current. Means firstly initialize the pointer that is head, and we will use for loop, and it will run until and unless when we get null. Okay, then after that we process means printing its each data, and next is move to the next, then next move to the next, then print that element, then move to the next. Okay, and how can we move, that is current next. Okay, so we will understand this through by the program. Okay, how we can do, firstly we take example simply. Okay, how we can traversal of single list linked list. Okay, so traversal of single linked list is the fundamental operation where we traverse or visit each node of linked list. Okay, in this article we will cover all the traverse, okay, all the nodes of single linked list, okay, along with implementation. Okay, so how we can traverse, actually here we use two approach here for traversal. Firstly we will use iterative, then we will go recursive. Okay, so how can we can traverse? Like that example, if take 1, 2, 3, 4, 5, and last one is consists of null, okay, then it output will come 1 to 5. Okay, means every element of each node from head to last node is printed, which means we have traversed each node successfully. Okay, same it is another example, 10 to 30, 40, 50, and null. Then it will print 10 to 50. Okay. Next one is also 5 to 25. Then it will print 25. Okay. It means it is successfully traversal. Okay. In all three cases. So, firstly, we will use iterative approach. How we can traverse singly linked list. Okay. So the process of traversing a single linked list involves printing the value of each node. Means what is the traversal of, what is the reason behind to traversal? Simply printing each node, okay, then going to the next node, then print that node, then going to the next node, and it will go on so on to the last node. Okay, okay, till we reach the last node in the single linked list, and when next node points toward the null. Okay, means if last node that is pointing to the towards the null means no more node is available, then it will finish. Okay, that work. So see how we are doing traversal operation. Okay, so we will initialize. Firstly, what a step is here for traversal of linked list. Firstly, we will initialize a temporary pointer to the head of node of single linked list. Okay, okay, temporary pointer we will. Okay, to the head node. After that, we will check if pointer is null or not null. Then we will write condition here. Okay, we will check. Means if next null is next pointer will be point to the null or it is not null. If it is pointing to the null means no node is here. Okay, then it will return. Okay, a pointer is not pointing to the null, then it will access that node. Okay, and then print that data of current data. Then pointer will move to the next node. Then it will print the data. Okay, it will goes on till we last node will pointing to the null. Okay, so we see how we will do. Okay, in last we defining the structure of node. Okay, firstly we write class node. Then it data type is here int, and it node next it is pointing to the next. Okay, this is for pointer purpose. Okay. Here I write constructor here, and it consists it is argument constructor. Okay, so int data, and simply in previous I already discussed, this is for the initialization of new node with data. Okay, so we will do this program in a eclipse also. How we got output. Okay, so in main firstly we see main. Okay, so in main firstly we write main. Okay, in this firstly what we do, firstly we define node. Okay, we temporarily define one means first node, that is head, that is node head equal to new node. Okay, 10. Okay, we give some data to this head. Okay, then this pointer will be point to the next node. Okay, head dot next, then new node 20. Okay, then this head pointing to the next node, then head dot next new node 30. Then again this head pointing to the is this node is pointing to the next node, then so that head next not next. Okay, so new node. Okay, so in main this is like I take some data in node. Okay, and here I write one method inside this main traverse list, and inside this I pass head. Okay, so we let's move what the logic I write here inside this traverse list. Okay, so inside this, let's move to the method part. So public static void traverse list node head. Okay, so we already discussed. Firstly, we will check by the while condition. Okay, if head is not null, okay, then it will pointing the data. Okay, next node. Okay, so what is that? While head is not null means then it will print the data of current node. So that system.out.println head.data. Okay. And I want a space between each element. Okay. So I provide a space. Okay. Then head equal to next node. So it will print next node. Okay. Like that, this will go till when head is not equal to null. Okay. So it will print each node in every step. Okay. One by one node. It will printed when will then node will last node will pointing to the null. Okay. Then so this is a logic for traverse list iterative approach. So we will see in this Eclipse. Okay. So for that I create one class here, traversal of link list. Select main from here. So firstly in main we'll take one temporary head. Okay. So that one is node So it will be node head temporary, node head, new, new node, and inside this I am passing some value. Okay. In same manner, I will take some value. Then head next will pointing to the next, and that also contains some value. This time it contains 20 head dot next dot next equal to 30 head dot next dot next dot next equal to node 40. Then next dot next dot next dot next equal to new node 50. Value I am taking here. 1 minute I am coming. I am that is Traversal. Just go above of option beside this. Actually, what a step I write a condition to check head is, then will head is. Then let's check what we can wrong here. Oh, forget to write data. That's why we are not getting here. And one more thing, you need to simply here write next equal to dot net. equal to, sorry, head equal to head dot next. So in this way we got all the elements. Okay. So don't forget to write data here. Okay. How you can get data. Okay. Head dot data, and after that, after getting, it will point into the next element. So head dot next. So like this, we got all the element which is present in a given linked list. So let's move to the another approach, that is recursive approach. That is easy. This thing is the same, and here some line is different here. In recursion, what we do? Calling the method again and again. So we write this method here. Okay, and this one two or line is different. Almost all the things are same. So, what is the time complexity? Big O of n, where n is the number of nodes in the linked list, and auxiliary space big O of 1. Okay. So, let's move to the another approach, that is recursive approach. Okay. So, we can traverse the single linked list using recursion. So, we start at the head of node, single linked list, check if it is null or not, then print its value. If it is null, then it can't print. Okay, means it doesn't contain any data. Okay, so if it and if it is not null, means it contains data. Okay, we then call the traversal function again with the next node passed as a point. So what is the step behind this recursive, okay, approach? So firstly, we define a recursive method to traverse a single linked list, okay, which takes a node as a parameter. In this function, the base class is that if the node is null, then will return. Okay. If you use any recursive method, then you have to write base case. So here base case is that if node is null, means it will return. Okay. So we then pass the head node as a parameter to this function. After that, we access and print the data of the current node. Okay. If it is not null, then it will pass the head node. Okay, to this function, and then after that we access and print the current node, and at last we will make a recursive call to this function with the next node as a parameter. Okay, so almost is same here. Okay, we already defined this. There is so here same thing is here. In main same thing. Okay, nothing is same, and in this only few line is changed. Means in if we use recursive approach, here simply I write method here just like previous one, and if you use recursive approach, then you have to write base condition. What is the base condition? If head equal to null, then simply system.out print means it will return. Okay, and if it is not null, then head dot data in just like previous example, and then we call the method. This is a recursive approach. Now what is the recursion? Calling the method itself. So we have to write this, okay, and inside this method what